Hello everyone, welcome back to part 2 of the Red Team training series. In this video we are going to be taking a look at Red Team Defense Evasion Techniques, more specifically how to bypass antiviruses, right? Now, as you can imagine, this is quite a lengthy subjective topic, and especially when you're talking about pen testing or red teaming. And we have a plethora of antivirus solutions out there. We're going to be working with a simple scenario, and we will be again modeling our attack methods based on the environment we set up and that we actually exploited previously. Now, when it comes down to what we'll be covering exactly, we'll get started by taking a look at the few antivirus detection methods, how antiviruses essentially detect malware or malicious code. Secondly, we'll take a look at some of the evasion techniques used by attackers, and then we'll move on to evasion with Invoke-Obfuscation, or the Invoke-Obfuscation PowerShell module, which allows us to obfuscate PowerShell code or PowerShell scripts for that matter. And then we'll take a look at evasion with Shellter, which essentially allows us to dynamically inject shell code or our payloads into a pre-existing PE or portable executable and have our shell code injected into memory. Now, when we talk about defense evasion and the MITRE definition, it essentially states the following. Defense evasion consists of techniques that adversaries use to avoid detection throughout their compromise. Techniques used for defense evasion include uninstalling or disabling security software or obfuscating or encrypting data and scripts. Adversaries also leverage and abuse trusted processes to hide and masquerade their malware. Other tactics or other tactic techniques are cross-listed here when those techniques include the added benefit of subverting defenses. Right, so as you can already tell, the objective here or the overall definition is not limited to antiviruses, but any defense systems in place, like an intrusion detection system or an intrusion prevention system. However, in this video, we are not going to be covering that. We'll probably have to cover that in its own video because it's quite an advanced topic, and it will depend on the intrusion detection system in place. That being said, let's take a look at some of the antivirus detection methods, or the methods utilized by antivirus software. So by default, antivirus software will typically utilize signature, heuristic, and behavior-based detection. So when we're talking about signature-based detection, an antivirus signature is essentially a unique hash that identifies a piece of malware. As a result, you'll have to ensure that your obfuscated exploit or payload doesn't match any known signatures in the antivirus database. So the way this works is whenever there is a new strain of malware, the antivirus companies generate a signature for that piece of malware, and again, if whenever a user installs an antivirus program or an antivirus system onto their computer, it'll also come along with an antivirus database. And if the antivirus system detects that same signature is on the system, it's going to quarantine the piece of malware, right? Now, as you can expect, signature-based detection is using a very, very simplistic method of detection, and that is, as I said, generating a hash of that piece of malware. So essentially taking or generating a hash based on the way the code is structured for a particular piece of malware. So that means that you can modify the malware's byte sequence, therefore changing the signature, similar to similar to the process of hashing a file, or whenever you have the unique hash of a file. If we make a single change to the file, the hash changes. So again, we can pretty much bypass signature-based detection by modifying the malware's byte sequence. The second type of AV detection is heuristic-based detection, which essentially relies on rules or decisions to determine whether a binary is malicious. So it does this by looking for specific patterns within the code or program or system calls, right? So now we're getting a bit deeper. So now we're using, when we talk about heuristic-based detection, what happens here is the antivirus software will look for unique patterns or specific patterns within the code, or will try and look for any program calls or system calls that the binary or payload is making, and of course use that information to determine whether or not it's malicious. The third method, which is becoming increasingly popular and implemented, is behavior-based detection, which essentially relies on identifying malware by monitoring its behavior. So what happens is the antivirus companies essentially execute a piece of malware in a sandbox and monitor what it does in regards to its interaction with Windows and the Windows kernel, and then uses or notes down that behavior and uses that to detect whenever this particular piece of malware is executed. So for example, as I've added there in brackets, it's used for newer strains of malware. If we analyze a piece of ransomware and we're using behavioral analysis, what we're doing is we're trying to identify what that piece of malware does. So we'll look at any changes to the registry, we'll look at any system calls being made or any Windows APIs being called or being used, and based on that we create a profile for that piece of malware, and then that is again used in detection. Now when it comes down to antivirus evasion techniques, there are basically two types of evasion techniques. You have on-disk evasion techniques and in-memory evasion techniques. Now when we talk about on-disk evasion techniques, we're essentially trying to bypass antiviruses through executing code or a payload that's stored on disk, right? So the execution and essentially the file and the code remains on disk. So again, the techniques utilized here are of course going to be obfuscation. Obfuscation refers to the process of concealing something important, valuable or critical. In the case of malicious code or executables, it essentially obfuscation reorganizes the code in order to make it harder to analyze or reverse engineer. You then have encoding. So encoding is essentially the process of changing data into a new format using a scheme or using a particular hashing algorithm. And encoding is as I've mentioned before, is a reversible process, so the data can be encoded to a new format and then decoded to its original format, and this is also used quite a bit. You then have packing, which is not done anymore, but the process is fairly simple, essentially using a packer to compress and generate a new executable with a new binary structure with a smaller size, and therefore provides the payload or the executable with a new signature. So again, you're rapidly trying to change the structure of the binary and reducing its size so that you can again get a very different signature. You also have cryptors, and cryptors are essentially used to encrypt code or payloads and decrypt the encrypted code in memory, which is also quite useful. The decryption key or function is usually stored in a stub. So again, what happens here is the encrypted payload or code, if you will, is stored on disk, and then the decryption function or the decryptor essentially decrypts the encoded code in memory, and it is then executed in memory. Right, now when we talk about in-memory evasion techniques, which are pretty much the most useful at this point in time, given the maturity of antivirus solutions out there, this essentially focuses on manipulation of memory and does not write files to disk. It essentially works by injecting a payload into a process by leveraging various Windows APIs. Now when I talk about a payload, I'm also referring to shellcode here. So what happens then is that the payload is executed in memory on a separate thread, right? So that's essentially how to, or that is the process of performing in-memory evasion techniques or performing process injection. Now, when we talk about the MITRE attack defense evasion tactics and the techniques that we'll be utilizing, we're going to be taking a look at obfuscation and process injection. So obfuscation will be on-disk evasion, and process injection will be in-memory evasion. So we'll take a look at these two techniques and how they can be facilitated. Right, so that being said, we can get started with the practical aspect of this video. So I'll see you back on my Kali VM. Alright, so the first technique we're going to be taking a look at is Defense Evasion with the Invoke-Obfuscation module. This is a PowerShell module that allows us to obfuscate and encode PowerShell commands and PowerShell scripts, right? So this can be very useful, and again, in this particular context, the target, in order for the target to run PowerShell scripts, they need to have the execution policy set to unrestricted. So those are one of the requirements for the target system. Otherwise, will not be able to execute PowerShell scripts, only PowerShell commands. Now, the reason I'm taking you through the process of obfuscating PowerShell scripts and PowerShell commands is primarily because it's extremely difficult or quite cumbersome for the antivirus to detect whether the PowerShell code or the PowerShell script is malicious, primarily because the code is being executed within an interpreter, right? It's not being executed like an executable. What that means is that we can utilize very simple obfuscation techniques, and that should pretty much provide us with a good chance of success in terms of getting our code executed, regardless of whether it is malicious. Now, when we talk about the Invoke-Obfuscation module or the Invoke-Obfuscate module, during the video where I explained the exploitation process, we utilized or I showed you how to set up the Invoke-Obfuscate module on Windows. We are going to be using PowerShell on Linux. So you might be thinking to yourself, well, I didn't know I could run PowerShell on Linux. Well, you actually can. More specifically on Kali Linux, you can actually install PowerShell using the aptitude package manager. So we'll say sudo apt get install PowerShell. And I already have it installed, so I'm pretty much good to go. It shouldn't take more than a few seconds to get it installed. Now, if you want to use PowerShell on Kali, all you need to type in is pwsh, which is an abbreviation for PowerShell. I'm going to hit enter, and voila, we are in PowerShell. And of course, you can again confirm that this is the case. So again, I can type in dir. It essentially lists the contents of this folder here, or this directory here. And the next step now is to import the Invoke-Obfuscation module. So similar to the exploitation video, you can download or clone the repository from the GitHub link provided to you in the description section. We then need to import the Invoke-Obfuscation PSD1 script here. And again, to do that within PowerShell on Kali, what we need to do is head over into the Invoke-Obfuscation folder. So again, make sure that that is cloned. You then want to say import module, and then we specify the module name, which in this case is going to be Invoke-Obfuscation.psd1. We hit enter. That's going to import it for us. The next step will be to, of course, launch it or to execute it. So we're going to say invoke obfuscation. And again, we just want to invoke the command because the module is already imported. So we'll hit enter, and there we are. It's working straight out of the box. And we want to give this a few seconds, right? All right, so welcome to Invoke-Obfuscation. As I've mentioned before, this tool can be utilized to essentially obfuscate or encode, compress PowerShell code or PowerShell scripts. Now, as I said, this is very useful when you want to utilize various PowerShell scripts to do various things. And we actually saw the implementation of PowerShell obfuscation with Empire. But I wanted to take you through the process of how to do it manually. So let's actually utilize a very simple scenario, yeah, right? So let's say we want to actually set up, or we want to develop a reverse shell with PowerShell, and then we want to utilize that PowerShell script on the target system so that when it's executed, we actually get the reverse shell connection. And the objective here, or the key here, is to essentially evade Windows Defender. Right now, if we do that by default, or if we do that using any weak encoding techniques like ASCII encoding, you'll actually see that Windows Defender will block that. So what we can do is the first thing we can actually do is actually get our PowerShell reverse shell code. So you can find that using the link in the description to the payloads, all the things GitHub repository, and we're looking for a PowerShell reverse shell, right? And we can use any of these any of these commands here. In this case, I'll use the second one. So I'll just copy that and I'll open up a text editor here. And what I'll do is, let me just change the preferences here. And again, if I let me just change the theme to Kali Dark right there, or let's actually use the Cobalt, which is much easier to read. So I'll paste the code in there. So this is essentially PowerShell code that'll actually spawn a reverse shell for us on our Kali VM. So we want to get rid of the PowerShell command here and the quotes. So I'll get rid of the quotes in the beginning and at the end, and then we want to change the IP that this particular script will connect to. In this case, it's going to be your Kali IP. So in this case, I'll say 192.168.2.21, and the port to connect back to is 1234, right? And then I'll save this as a PowerShell script. So I'll head over onto my desktop and we'll say red team. I'll save it under here. So I'll just call it shell.ps1, we can just save it as like that. So this is a unencoded PowerShell command, and if we try and execute this on the target, we pretty much will be given an error. But again, we're not going to do that. We're actually going to try and encode it with one of the encoding techniques provided for us within the Invoke-Obfuscate module. So now that we have that saved, what we can do now is let's head back into PowerShell. And again, the tool is fairly simple to use, and the documentation is fantastic. So you have your options here that you can provide, but these options are only going to be useful once you've set the script that you actually want to obfuscate. They also have a great tutorial that'll take you through a simple scenario that'll actually show you how to use the tool. So the first thing we want to do is we want to set the script here that we're using. So in this case, if we want to set the script path, so we can say set script path, and that's going to be the actual path to the PowerShell script that we want to encode. In this case, we know we saved it on my home Kali account desktop under a folder called red team, and it is called shell.ps1, right? And yeah, so that looks okay. If that's successful, it's going to tell you successfully set the script path. What we can do now is we can actually encode the entire command, or the script rather, as you know, in various ways, and I'll actually show you the various ways available. So for example, if I say encoding, you can see that it gives us various encoding options here. So we can encode it as ASCII, as hex, as octal, as binary, as secure string, which works really well. As you can see, it uses AES. So we can use option 5 here. So I'm going to say option 5. And you can see it's going to output that into AES, or an AES encoded command here. So what we can do is we can actually copy this, or we can actually output it. So what I will do is we will actually copy it, right? And we will save it as a new PowerShell script. So I'll just copy that, and I'll open up my text editor, and I'll create a new file here. And again, we will save it. We will save this as under the red team directory. We will save it as reverse shell.ps1, or we'll just say we'll just call it reverse shell.ps1, and we'll hit save, and that's the reverse shell, and you can see that that's been encoded, right? Now we can actually transfer this particular reverse shell.ps1 script onto the target. So I'm just going to set up a new terminal here, and I will use the simple HTTP server module for Python to essentially start up a local web server. In my case, I have an alias for it. It's the serve command, and that will serve all the files within the red team directory for me on the Kali IP under port 80. So I'll move on to my Windows VM, and then we can download the PowerShell script, and let's see if it's executed successfully. But again, just to make sure that we can actually verify whether it executes successfully, because this particular PowerShell code is a reverse shell, we need to set up a listener on port 1234. This can be done with netcat. So netcat nvlp 1234, we hit enter. So I'm going to switch over to my Kali VM now. Alright, so I'm on my Kali VM, and I've downloaded the PowerShell script. You can see that Windows Defender is enabled, although I have disabled cloud delivered protection and automatic sample submission in the event that our code is detected. We don't want any of our malicious code being submitted to Microsoft, but real-time protection is enabled, right? So we will execute this here. So we can say run with PowerShell, and we'll just hit open, and it looks like it executed that. However, I'm not sure whether it actually was successful. So I'm going to try that again. Alternatively, what we can do is we can actually try and we can actually try and execute it manually using PowerShell, but we will actually do that in a second. Let me just switch over to my Kali VM and let's see whether we got anything on our listener. We didn't get anything, so again, that it looks like that was detected. So we can actually take a look at a few other encoding techniques with Invoke-Obfuscate. So I'm just gonna again, let me just clear this out, and let's take a look at how to use a few other techniques. All right, so let's take a look at one of the best techniques. So what I'm going to do is let me just exit out of here, and we're just going to say invoke obfuscate one more time, or obfuscation rather. I just want to take you through one really useful technique. So we will use the same PowerShell script, this one shell.ps1. And again, I'll just set the script path first. So set script path, and we will set this to home, Kali desktop, and this is under red team, shell.ps1, right? And we hit enter. That's successful. We will obfuscate the PowerShell AST nodes. Now this only works for PowerShell 3 and above. This is a very, very useful technique. It actually is quite successful at evading detection by Windows Defender and a few other antiviruses. So we will say AST. We're going to essentially use the all option here. This is going to use all choices from above, so it'll obfuscate all of the PowerShell AST nodes here, and it'll actually show you which AST nodes it utilizes, or it actually obfuscates. So we will say all, and then we'll hit option 1 to execute all AST obfuscation techniques. We hit enter, and you can see that it's obfuscated all the PowerShell AST nodes, and we can then copy this and then again save it as a PowerShell script and then transfer it over to the target, and let's see whether we can execute that. So what I'm going to do is again just create a new file now, new, and we will save this as let's save this, let's see, we'll call this obf.ps1, or we'll just call it obfuscated .ps1, just so that we know that that is the correct one, and then we hit save. Right, all right, so that has been saved. So I'm now going to head over onto my Windows VM and let's see whether this actually works. All right, so I'm back on the Windows VM, and I'm just going to run this with PowerShell here. So I'll click on the script, run with PowerShell, and we hit open. And that looks like it is successful because it essentially opened a simple command shell. So let's check out our Kali VM and let's see whether we got any connection back. And indeed we got a connection from 192.168.2.2, which is the Kali, which is the Windows VM. So if I, for example, type in dir, we can see we get the directory listing here. We can also say ipconfig. And there we go. We can see we get the correct IP information, which again, this particular virtual machine is connected to the NAT adapter, which is why you're seeing a different IP here. But you can see it is the IE user, and we're in the downloads folder where we executed the script. So you can see how useful the Invoke-Obfuscation module is when it comes down to essentially obfuscating or encoding PowerShell scripts and commands, and how they can be used to evade antivirus detection. So I just wanted to cover that technique because it is quite useful, because again, as you already know, when you're performing red team operations, PowerShell is pretty much the best option when it comes down to again executing specific commands or running particular jobs or tasks. Now that we've explored this technique, let's take a look at how to use Shellter. So I'm just going to clear up my terminals, and I'll see you in the next stage where we will actually take a look at how to use Shellter. Alright, so if you're not familiar with what Shellter is, by the way, it's spelled Shelter with a double L, so that's not a typo. Shellter is a dynamic shellcode injection tool and the first truly dynamic PE infector. PE stands for portable executable, ever created. It can be used to inject shellcode into native Windows applications. Currently only 32-bit applications only. The shellcode can be something yours or something generated through a framework such as Metasploit. So for example, we can utilize or generate shellcode or shellcode, for example, for a MITRE payload, Windows MITRE payload. So Shellter takes advantage of the original structure of the PE file or the portable executable file and doesn't apply any modification such as changing memory access permissions in sections unless the user wants, adding an extra section with read-write access and whatever would look dodgy under an AV scan. Shellter uses a dynamic approach which is based on the execution flow of the target application, and this is just the tip of, the actual tip of the iceberg. So Shellter is not just an EPO infector that tries to find a location to insert an instruction to redirect execution to the payload. Unlike any other infector, Shellter's advanced infection engine transfers the execution flow to a code cave or to an added section in the infected PE, right? So this is how it essentially works, and these are the features here. So again, it's portable, doesn't need a setup, doesn't require any dependencies, it doesn't generate any static PE templates, supports 32-bit payload. It supports 32-bit payload generation, compatible with all types of encoding by Metasploit, which is great, and much more. So again, this is really smart and works very differently than other injectors that you may have seen previously, in that again, it utilizes a portable executable, and of course this is now where your ingenuity will actually come into play. So for example, we can take a simple scenario, and I'll try and explain what this tool does really simply. So what this does is it takes a legitimate executable. The executable will typically be an installer or a program that a user may be tempted to click on, and it takes this executable and injects shellcode, the malicious shellcode, into the portable executable. And as it says here, it doesn't apply any modification such as changing memory access permissions or anything that might be dodgy under an antivirus scan. Shellter uses a dynamic approach which is based on the execution flow of the target application. And as I said, this is really cool. So in our particular scenario, we can take a setup file or an executable like WinRAR, and then we can inject our shellcode, which is going to be a MITRE shellcode, and we can essentially backdoor the WinRAR executable so that whenever it's executed on the target system, it then of course sets up the process in memory, the shellcode process in memory, and it's then executed in memory insofar as that application is running. So we can actually do this right now. Now, as I said, Shellter already comes pre-packaged with Kali, and you can locate it under the I'll actually change my directory into the user share Windows resources directory. And again, it is an executable file or an exe file, which means we can run it with wine. So there we are, there's the Shellter directory, and if we list the contents here, you can see we have shelter.exe. All right, now before we do that, we actually want to download our target portable executable, or the executable that we are going to be essentially injecting our shellcode into. So I'll just search for WinRAR. I will use this as an example as it's quite portable and quite small and doesn't complicate things. We'll click on download here. We want the exe version, so we'll click on the platform as Windows, version 5.7.1, 32-bit, because Shellter only works on 32-bit executables. And we will click on WinRAR. We can again just click on the one here. So for example, we can say if we only want English, based on your target language, and just search for those ones there. So there we are, WinRAR 6.02, English 32-bit. So we'll save that exe file. There we go. And we want to preserve the actual name. So again, I'm just going to head over into my downloads. That's where it saved it, and we can see WinRAR 602.exe. So Shellter will inject our malicious shellcode into this executable, and then we'll transfer this executable onto the target and execute it. And if everything is done correctly, then we should be able to bypass Windows Defender and receive a connection back on our listener with Metasploit. So we'll launch a shelter, or we can actually launch shelter really simply by typing in, we'll say sudo wine, and we'll just say shelter.exe, right? We hit enter. And there we are, shelter is going to start up. So by default, we're not going to cover the manual modes because that's quite advanced. We're just going to use the automatic mode. So we'll use A and we'll hit enter. The PE target is the WinRAR executable. So we're going to say home Kali downloads. And let me just make sure I get the name right. So that is, I'll just copy the, so I'll just say rename here. I'll copy the entire name there, so I'm making sure nothing is wrong. I hit enter. It's going to back up the original executable under that particular directory, and it's now going to again go through the process of, I'll take you through it here. It's going to check for the compatibility. It's then going to take a look at the whether or not this portable executable is packed. It's then going to go through portable executable info elimination. So again, it'll then move on to the most important stage, which is tracing. So it's going to say tracing has started, and you can use Control-C to interrupt tracing at any time. In auto mode, Shelter will trace a random number of instructions for a maximum time of approximately 30 seconds in native Windows hosts, and for 60 seconds when used in Wine. So again, we're going to give it 60 seconds here. So I'm going to get back to you when this is done. All right, so it's going to ask us whether we want to enable stealth mode. We're going to say yes. So I'm going to hit yes there. It's now going to ask us for the payload that we want to inject into this executable, and it'll give us a list here. So it's going to say use a listed payload or a custom payload. We're going to use L for listed. We are going to use, let's see, we can actually use Meterpreter reverse TCP. That'll work well. We hit option 1. Set the L host as the Kali IP. So 192.168.2.21 in my case, and I will set the L port as 1234, right? You can set that to whatever you want. It's now going to begin building or injecting the shellcode. So there we are. It looks like that is done. Injection verified, and we can then hit enter to continue, and it's going to again, once it's done, we can, this is going to be the malicious executable. And as I said, it took a backup of the shelter of the WinRAR executable, and it stored it within user share Windows resources shelter under shelter backups. So for example, if I head over into shelter backups, you can see we have the original executable here in the event that you want to use it again. So what I'm going to do now is I'm going to essentially transfer that WinRAR executable onto my target system. So again, I'll just serve the files within my downloads directory. Let me just provide my password here, and I'll now head over onto the target system, download the executable, and we can then execute it. But before we do that, we of course need to set up our listener with Metasploit. So MSF console, and again, give that a few seconds there. We're then going to say use multi-handler, and we then want to set the payload to Windows Meterpreter reverse TCP, and set the L host option to 192.168.2.21, set the L port option to 1234, and we then want to hit run. Now it's important to note here that there's something very important that's going to happen, and that is when we will execute the WinRAR executable, because it's an installer, the user will not know what's been whether or not the shellcode has been injected, and of course we will get the Meterpreter session, but when the user closes down the WinRAR the WinRAR installer, when they're done, our Meterpreter session will die. So we actually need to use, or we need to migrate the process into another process. So we can use the auto run script. So we can say set auto run script to let's see, post Windows. Let's see if I can actually remember it. So post Windows, and we will say manage and migrate. So it's going to migrate it automatically for us, and then we can hit run. Right, so again, where it's not going to wait for any connection. So I'll head on to my Windows target now. All right, so I'm on my target and I downloaded the executable, and so far the antivirus hasn't picked this up. And you can see it looks exactly like the installer, the WinRAR installer. However, the only difference is that this particular installer is not signed, and so Windows might give you a warning here. So again, if we hit run, you can see it's going to tell us that it's not signed, unknown publisher. So we'll run anyway, and we can just hit yes, and you can see it's going to open up the installer, and the user can go about installing it. And again, you can see for some reason it was shut down. If we check Kali here, we can see we got a MITRE session and it migrated and shut down the installer there. So again, if we say sysinfo, you can see we've gotten access, and Windows Defender hasn't shut us down, and we've obtained our initial access to our target system using a malicious payload or a malicious executable that was successfully able to evade Windows Defender, and will probably evade a few other antivirus systems or antivirus solutions. Now, the reason why I'm not using any other system or using VirusTotal is because in this case, you can see that this did actually work, and it's very important to note that if we submit this particular binary or executable to VirusTotal, VirusTotal will use the hash and will actually provide it to antivirus companies, and as a result, this particular technique won't be viable anymore. So you can see that in this case, it did work, and again, you know, we can pretty much let me just type in get user ID. You can see we're currently an unprivileged user, but we were able to get access. So of course, the next logical step would be to set up a system of persistence. That being said, that's pretty much all that I wanted to cover in this video. As I said, we're primarily focused on antivirus evasion as a defense technique. I will probably be exploring you know, other evasion techniques in future videos, but that's all that I wanted to cover in this video, and I'll be seeing you in the next video.